Welcome. Now we're going to learn how to solve absolute value inequalities. We'll look at the absolute value of x is less than 5 first. And I think it might be helpful to look at this on a number line to see where we might find the solutions to this. So here's a number line. And first we note that, well, all of the positive numbers that are less than 5, like 1, 2, 3, 4, and 0 even, those are all going to be part of the solution. So anything right here and right up to 5, but not including 5, so we'll leave a hole there. But all of these other numbers have an absolute value that are less than 5. But now let's look over here to the left. Negative 1. The absolute value of that is 1, and 1 is less than 5. And the absolute value of negative 2 is 2. That's less than 5. So all of the numbers on this side of the number line up to negative 5 also have an absolute value less than 5. Now we can also look at this as a combination of two inequalities, a compound inequality. This is a combination of the numbers that are less than 5 and also the numbers that are greater than negative 5. So if we take all of the numbers that are both less than 5 and greater than negative 5, we've expressed the meaning of the absolute value of x is less than 5. And if we look at how we would write that, not represented on a number line, but write it, this is the way we'd write it. X is less than 5 and x is greater than negative 5. Now the first step in solving an absolute value inequality that looks like this is to do the following. We're going to split it up into the two problems that we have right here. Those are going to be x is less than 5 and x is greater than negative 5. So we're going to split it into those two problems. And this is how we approach absolute value inequalities. Now we'll take a look at how to solve some problems. And we're not going to go through the steps in detail because you already know how to do many of them, but we'll look at the overall approach and focus on the beginning of the process. So we'll take the absolute value inequality, the absolute value of x plus 3 is less than 11, and we'll split it up into two different problems. First, x plus 3 is less than 11, and then x plus 3 is greater than negative 11. It's similar to what we did with absolute value equations, except that you have to remember to switch the sense of the inequality or flip the inequality as you solve these. So we split this into two problems, and then we solve each of the problems. We subtract 3 from each side, and we get x is less than 8 and x is greater than negative 14. And you can follow the math here. If we were to graph these on a number line, we would want all of the numbers that are both less than 8 and greater than negative 14. So that's all the numbers here in the middle. Now, we can also write inequalities this way. We can say, this is another way of writing all of the numbers between negative 14 and 8. All right, let's take a look at this next one. So 2x, absolute value 2x plus 3 is less than or equal to 13. Now we split this up into two problems. 2x plus 3 is less than or equal to 13, and 2x plus 3 is greater than or equal to negative 13. Okay, so we have to remember to flip the inequality or change the sense of the inequality and then move ahead. Okay, so we'll subtract 3 from each side, divide each side by 2, and we'll come up with x is less than or equal to 5 and x is greater than or equal to negative 8. The graph will look something like this, and we can state the solution to the problem again either this way or this way. Either of those is fine. Now I'd like you to try these two problems, these two inequalities, copy them into your journal, stop the video while you solve them, make a graph, and then restart the video to check your solutions. Okay, now let's take a look at the solutions. So for this one, we would split this into two problems. Y is less than y minus 5 is less than or equal to 12. And then y minus 5 is greater than or equal to negative 12. We subtract, we add 5 to each side, and we get this solution: y is less than or equal to 17, and y is greater than or equal to negative 7. This is what it looks on a graph. Y is less than 17 and less than or equal to 17, and y is greater than or equal to negative 7. And notice that the endpoints have been colored in because those are part of the solution. And we can also write our solution this way: negative 7 is less than or equal to y, which is less than or equal to 17. Here on the right, absolute value of 9a minus 1 is less than 17. We split this into two problems. 9a minus 1 is less than 17, and 9a minus 1 is greater than negative 17. Add 1 to each side, divide each side by 9, and notice that the solving steps are the same for both sides, but the answers on each side are different because of the signs. So we have a is less than 2 and a is greater than negative 16/9. This is what the solution looks like on the number line, and you can also write the answer this way. Now let's take a look at a different type of inequality. Now it looks kind of the same, but there is a difference. So here we have the absolute value of x is greater than 10. And let's start by looking at a number line and see where the solutions to that might be. Now, if we start at 10, well, 10 is not greater than 10, so 10 is not part of the solution. But how about numbers bigger than 10? So how about 11? Well, 11 is a solution, and 12 and 13 and so on. So all of these numbers to the right of 10 on the number line, all of these numbers that are greater than 10 are solutions to this inequality. But there are other solutions. Now, if we take a look at, let's say, negative 10, that's not a solution. But how about negative 11? If we substitute negative 11 for x, the absolute value of negative 11 is 11, and 11 is greater than 10. So this is a solution. And so are all of the numbers to the left of negative 10. Now this is a type of graph that we've seen before in compound inequalities. This includes all of the numbers greater than 10 or numbers that are less than negative 10. Now you cannot have a number that is both less than negative 10 and greater than 10. One number cannot be that way. So really what you're looking for is all of the numbers that are greater than 10 or less than negative 10. And that's exactly the way we would write the solution to this inequality. X is less than negative 10 or x is greater than 10. And the or is important. It is part of the solution. Now if we were solving this, we would split it up in much the same way as we did the other problems. We would take the absolute value of x is greater than 10, and we would split that up into x is greater than 10 or x is less than negative 10. So this is the way we're going to split up absolute value inequality problems where the absolute value is greater than a number. And let's see a couple of examples. Let's take a look at the problem absolute value of x minus 3 is greater than 6. So the first thing to do is split this up into two problems. X minus 3 is greater than 6, and x minus 3 is less than negative 6. And once again, you have to remember to switch the sense of the inequality and make the constant negative. So we will add 3 to each side, and we will get x is greater than 9 or x is less than negative 3. We can put that on a number line this way. This is x is greater than 9 or x is less than negative 3. Now, a warning. This is not correct. 9 is less than x, which is less than negative 3. Because if you think about it, what this is saying is that x is at the same time greater than 9, but also less than negative 3. So when we have or inequalities, we never ever write them like this. Let's take a look at the second problem. 7x minus 2 is greater than or equal to 12. So we split it into two. 7x minus 2 is greater than or equal to 12, or 7x minus 2 is less than or equal to negative 12. We add 2 to each side, divide each side by 7, and our solution is x is greater than or equal to 2, or x is less than or equal to negative 10/7. We can put those numbers on a number line and make a graph. And once again, we remind you that writing the answer this way, 2 is less than or equal to x, which is less than or equal to negative 10/7, is incorrect. It is not the correct way to write the solution. Now I'd like you to try these two problems. Please copy them into your journal, stop the video while you solve and graph them, and then restart the video to see the solutions. Alright, so for the first one, we're going to split this problem up into two problems. 5 plus x is greater than 4, 5 plus x is less than negative 4. We'll subtract 5 from each side, and the solution will become x is greater than negative 1, or x is less than 9. And here's what the number line solution looks like. For the second problem, the absolute value of 3x minus 6 is greater than or equal to 5. We split this up into two problems. 3x minus 6 is greater than or equal to 5, or 3x minus 6 is less than or equal to negative 5. We add 6 to each side, divide each side by 3, and we get x is greater than or equal to 11/3, or x is less than or equal to 1/3. The solution on the number line looks like this. And remember that when you write the solution, you will be writing this part of the solution this way, and then giving the number line solution. And there you go.